Welcome back, algebraists. Again, I do want to stress, today, I guess in 2025, is September 15th. Your homework did not match the assignment that we talked about last class. Okay, on Friday, we looked at systems in 3 variables. We have not done practice with that because, again, Holloway messed up. You will have plenty of time today. The last little focus, and we're just going to continue on. This is a straight continuation in 1.6. We talked about systems of equations. We did 2 variable, elimination, substitution. And then we did 3 variables, which are also just elimination and substitution with an extra step included. Okay, today we are going to continue and finish with systems of inequalities. Inequa is my shorthand for inequalities. I assume that you would probably gather that. Now, we did a bell ringer last Friday, I believe, focusing on this basic idea. And if you don't remember it, when we're solving systems of equations, we have to use a graph. Now, the most challenging part is deciding where to shade. Today, that'll be our focus, because most of you guys can graph the line, and the line. But then figuring out where to shade is an issue. I am never going to require it, but I would recommend these bad boys to help you keep stuff straight. You do not have to use them, but if you want colored pencils, I will always change colors up here. I can show you how I would do it if I didn't use colored pencils, because there are nice ways to organize it. So let's jump in. Okay, when we're dealing with these, first little comment I want to make. These things have whole regions on the plane for their solutions. Whole regions of plane for solutions. Now, I don't love graphing, and I'm talking at you guys as you're writing, so whole regions of plane for solutions. So I will hold up for just a moment. Inequalities, we don't have just a single point where they meet. That's not what we're after. We're looking for any ordered pair that satisfies all of the inequalities. It winds up being ultimately that there are infinitely many, and there's no good way to write that other than to graph it and show where that region is on the coordinate plane. So when we're doing these, whole regions of plane for solutions, and there's only a few little things. So we're going to go through the steps just really briefly, and I'll try to do these as concise as possible so that we can get a couple examples and then have plenty of time for homework stuff. Okay, when we're dealing with systems of inequalities, step 1 is going to be graph each inequality. Graph each inequality. And pretend we have an equal sign. Okay, we'll talk about what that means, but the inequality part of it is where people can get pretty confused with it. We'll just graph the equation like it's an equal, and then we'll deal with the inequality part after the fact. So, when we graph these, just like we saw before with piecewise, there's a difference between an included point and a non-included point, right? We had open circles and closed circles. How did you decide if it was closed or open? If it was closed circle, how did I know that? Something about the inequality in the boundary. Or equal to. So check it out. There's a similar statement here. If it's or equal to, and I'm going to write it like this, but remember it'd be the inequalities. So less than or equal to, or greater than or equal to. We use solid line. If we had a hole in our piecewise equations or a piecewise graph, that was when there was just greater than or less than, right? So we'll say greater than or less than, and I'll make this one just with this so we can save a little bit of writing. Instead of a solid line, we will use a dashed line. Okay. So we can graph each equation independently, treating it like an equal, before we actually commit to drawing it. We need to pay attention. Is it going to be solid or dashed? Now, when we get a couple of lines on our graph, we're going to see that it splits the entire plane into several regions. If there's 2 inequalities, there's probably going to be 4 regions, most likely anyway, but we'll deal with it as we go. From here, once we have a graph, step 2 says test a point not on the line Okay. What's the easiest point that I'm going to test like 99% of the time? 0, 0 is going to be the go-to if I can. We're going to test a point on not on the line. If true, shade region or regions with point. Now, that's the test point that I'm referring to. And let's see how our powers of deduction work. If it's true, I shade the region with the point. What if it's not true? Shade other region. Now, it'll get more clear once we do an example, but we'll go ahead and say if false, shade other region. Okay. Lastly, the very last thing that we need to do to finish these up, we have a bunch of regions shaded, is identify, and I'm just going to use ID, the region shaded by all inequalities. Okay. Now, we could probably spend some time and make this a larger sort of setup and make it more steps, but for now, I'm comfortable with these. If you guys have these steps on your page, I'm going to scroll down so I can like work on a whole blank page here, but keep these up. Let's run through it and make sure that if we have any issues, we can sort it out. Before we jump in, I don't know if I mentioned it yet, the Cowboys won yesterday, so just in case anybody hadn't known that. All right, let's do one. Example, I'm just going to say solve, because we're solving a whole system of inequalities. Cool. So let's find one. I gave you guys 19 and 20. Whoops. And let's knock out a nicer one, because I have convenient examples. All right, so here we go. For our first one, together, we're going to do a big one. I want 2x plus y. 2x plus y is less than or equal to 14. There's my first inequality. The second inequality is x, and I'll switch colors every time. You know what? I'll do this at the end. I'll show you how I actually do it if I'm doing it on my page. X plus 2y is less than 10. Two more coming. We get x is greater than or equal to 0, and we get y is greater than or equal to 0. Here's our lovely system of 4 inequalities. Now, because I'm trying to show like how I would do it if I was doing it on my page, normally we would all write in black regular pencil to start. I think that's reasonable. What I will do then is I will then, on my graph, I'll pick a color and I'll indicate it here so that we can really see which one's which. If you want to use only your pencil all the time, you're cool to do so, but you have to label your equations, your lines on your graph. So let's dive right in. First thing that I see before I set up my big 10 by 10, the bottom two inequalities automatically are going to stick me somewhere nice on the coordinate plane. 30 seconds, chat with your neighbor and tell me how big of a graph should I draw. Do I really need all of this is the question at hand based on these two. Talk with your neighbors. We'll come back together 30 seconds. Because we have x and y greater than or equal to 0, I think that we're primarily going to be stuck in quadrant 1. You can draw the whole thing if you want, but I think that it is worth our time to realize that, oh yeah, most of it's going to be over here just in this very positive part. Okay, you are allowed to graph the whole thing if you want. Don't care if you want to do that, but you're going to waste a lot of space and we'll get a better picture if we're more zoomed in. Okay, for each of these, I'm going to switch colors, and now one of them I'll do black so that you can see there. Here's my first one. First thing that I care about, is this going to be a solid line or a dashed line? Solid. So I'm going to use a solid red line, and that'll help me remember that, oh yeah, I'm going to graph this with a solid red line. If I wanted to graph that top one, we're going to pretend like it says equals right now. We'll deal with the shading in a minute. For the top one, I'm not going to solve it for y equals. And I know that I could, negative 2x minus 14, or plus 14, sorry, but there's an easier way. If x is 0, it's like y is gone. What would y be equal to? So I'm going to plot the point 0, 14. Now I'll pick a scale here real quick. I know I need to go to 14. Am I going to make 14 little ticks? Not a chance. What do you think I should jump by? 2 would be okay, but I'm lazy. 4. What if I do 5? 10 and 15. And again, I'm not doing it perfectly, but these are fairly consistent. I'm pretty close. Cool. I know that I get the point when x is 0. What do we say y was? 14. Before we continue on, somebody in here, I'm pretty sure, does not understand how I just got that point. Now would be the chance or the time to ask that question. So, Kennedy, I'm not like, just because I saw your face, and thank you for your honesty. If x is 0, we just get y, and we're treating this like equal. If I let x be 0, do I just get y equals 14? On the very top equation. So pretend that this is an equal sign right here, and if x is 0, what would y be equal to? Boom. Here's the point 0, 14. That's all we did. When y is 0, like this, what is x going to be if it's equal to 14? 7. Everybody okay with that? Okay, so I'm going to jump by the same scale here, and I'll eyeball out where 7 would be. And let's see. Do you want it to be square? Or can I go out to like, here's 5? Does that bug you guys? Okay. We'll get over that eventually, but there's 5 then. And here's roughly 10. About the same, right? Okay. So we just found that when y was 0, x was 7, which I think looks about like that. Everybody okay with those 2 points? And in fact, I'm going to put that other point there in a second. Now I'm going to draw this with a solid line. And we'll try again. I should start down here so it passes through 7. There, boom. Okay, if you are using just black, and that's okay, you're allowed to, right? If you're only using one color, you better make sure that you include the equation with that line, because we're going to have multiple. We don't want to mix them up. Now, there are some shortcuts that we're going to take, but we'll deal with that here in a second. Let's graph the blue one, or the second one. I'm going to use blue. First thing that I care about, Freddie, on this second equation, am I going to use a solid line or a dashed line? Solid. Are you sure, and why?
Oh, dashed.
Why?
Because of the...
Check your notes if you need to. Look at the last thing we wrote. Solid if it's or equal to.
Oh, because there's no equal to.
Good. So I'm going to use a dashed line for this one. And here I will indicate that. Cool. If x is 0, like it's gone, what would y be equal to? 5. Okay, so here's y equals 5. And if y is 0, what would x be? 10. Okay, same thing. I will draw through these, and it's going to look like I make a mistake, but I just come back and erase mine because I have, the capability. So I will come back and I will erase, so it's a very clear dashed line. If you are still on the opinion that you'd rather solve for y equals, that's okay, you can do it, but I promise this is faster and easier. Okay, these last two are kind of strange, and they're going to be ugly on the graph no matter what. How do you draw the line x equals 0? So I'll start at the origin, here's 0, 0. Which way does that line go if x is always 0? It's a vertical line. Now, both of these are solid. I'm going to bold it because if it's on the axis, I struggle to see it. But we'll say solid. I'm going to make it really bold so I can see it. Here's one of them. That's x equals 0. And it just happens to be the y-axis. And it's actually x is greater than or equal to 0, but we'll deal with that here in a second. And then the last region, it's this lovely, I don't know, pinkish color. Where's y equals 0? What line is that on my graph? The horizontal. So I'm going to draw it just barely above it, and I'll label it. Y greater than or equal to 0. What do you mean?
What X is supposed to be.
I don't think so. If you pick, like, at any of these ordered pairs, Sebastian, what is the X value? At any of these, like, give me this ordered pair right here. Don't plot it on yours. Just tell me what ordered pair this is. 0, 10. How about this one here? How about this one here? 0, negative something, right? What was X always? X equals 0 is a vertical line. Cool. All right. Now, for the sake of conversation, I'm going to ask you guys, I'm going to give you about a minute. I want you to count how many regions we've cut the plane into. Now, I'll help you with the first couple, and I just want to see that, man, there's some weird parts of this. I think that, don't shade yours, I think here's a region up here. So everything, and I'll go ahead and get this bad boy. All of this is a region that I've just shaded. There's one of them. How many more regions did we create on our graph? I'm going to give you guys about a minute. Try to count them. I'm going to label them on mine. You don't have to do it normally, but I just want to make sure we can all appreciate there's a lot. Okay, about 60 seconds. There are a lot of regions on this graph. Now, I would not encourage you to write these numbers down. This is just for us talking. I think there's that first region that we just did in orange a second ago. Everything up here. I'll call that region 1. Okay, is there a region stuck between these two lines? So there's 2. Is there a region between red and green and blue all the way over here? Okay, so there's 3. There's one between blue and green and purple. There's 4. There's one down here in quadrant 3. That'd be, I'm going to get rid of that. There's 4. Here's 5 down here. 6, 7, 8, 9, and 10. Oh, hold on. 11. There's 11 regions on this graph. Okay. This guy right here. Yep. Now, there's a lot going on, right? Okay. As we look at these, I'm going to keep these numbers up. I wish I would have used a different color, but we'll survive. As we're looking at these, some overlap is going to hit all of these. Now, when you guys did this in Algebra 1, depending on who your teacher was, and I lied, I'm going to get rid of all these numbers because it's going to drive me crazy. When you guys shaded, I have the sneaking suspicion that sometimes you guys might have done something like this. Anybody ever done that before? If we have, like, and then maybe this one gets this way, and then just look for where they all overlap, right? I think that is awful. I think that's hard to follow. It works, don't get me wrong. Like, it does work. I just think it makes it too ugly to find. Let's deal with each one independently, and then when we get a little practice, we'll start to see that maybe I can think these things out as I go. Let's run this one first. Okay, I'm going to pick that very first equation, and I'm going to do a bunch of scratch work down here, and we're just going to check some stuff. I need to decide, once I have them graphed, where I'm going to shade, right? Okay, what test point should we use if possible? So we're going to test 0, 0 on almost all of these, at least the red and the blue. Purple and green we can't, but those are easy to make sense of. If we do this point, 2x plus y, or this equation, is less than or equal to 14, and we test 0, 0. Because all I require is any point that's not on this red line. 0, 0 is not on the red line. I'm going to try it. Let's just see what happens. I get 0 plus 0 is less than or equal to 14. 0 is less than or equal to 14. Is that true or false? That's true. Now, each independent line cuts the plane into 2 pieces. If 0, 0 was true, it means that every region underneath, like this, would have gotten shaded. Don't draw it yet. Everybody cool? Instead of doing it like this and doing hashes and changing the angle, here's what I'm going to propose. Any region that would have got shaded, I'm just going to put an X in it. So here's this region. It's underneath X, 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 and X. Yes, sir?
When it's true, or which way is it if it's true and it goes down?
So I'm not going to tell us to think about less than or equal. Like, I'm not going to think about it like that. We tested 0, 0 and saw it was true. So every region down here gets shaded. Every region where 0, 0 was a part of underneath the red line. Does that answer it? Okay. Did I miss any regions on this side of the red line just now? I don't think so. Okay. What point should I test the blue line with? 0, 0. Love it. I'm going to. That's a good idea. So we have x plus 2y is less than 10. And if I plug in 0, I get 0 is less than 10. True or false? True. Now, again, I just want to stress, what that means is that everything down here would have gotten shaded. So any of the regions that I would have just hit, I'm going to put an X in. So let's see, there's a bunch of them. An X here, and here, 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 and here. That's every region underneath. Any big questions yet? Okay, these last two, the green and the pink. I don't know that I would really do the test here. Can we use 0, 0 to test the green one? No. Can you give me any point that's not on the green line? 1, 1. If I plug in 1, 1, 1 is greater than 0. True or false? True. Additionally, can you guys tell me what side of the green line should be positive? The right side. So if we're okay with that, that's what I would propose. Everything to the right of green gets shaded, right? So any region to the right, I'm going to put a green X in. So this one down here got one. He gets one, there, there, and there. Only one more. What does it mean if y is greater than 0? Is that above the y or the x-axis or below it? Above. Are we okay with not using a test point there? So every region above gets an X. There's a lot of them. Okay. There's a lot of work that goes into these. You will get better at it. We don't physically have to write all the X's every single time. It takes a little practice. We'll start to see there's some shortcuts. How many inequalities did we have in our original system? 4. Is there a region that got shaded 4 times with 4 X's in it at this point in time? Yes. It's this little foregone down here, right? So instead of having hash marks and making our pages all ugly, if we've identified that singular region that got shaded by all 4 of them, we're good. This is too thick of ink, so we'll do this. Everything down here just got shaded, and look at that. What we have is some region on my coordinate plane where any ordered pair that you ever pick in here will satisfy all 4 of these inequalities. And we are done. Okay, this problem with 4 of them is pretty involved. Before I ask you guys to do another one, questions, concerns, issues, parts that you didn't understand before we dive right in. Help me pick a point in here. Give me some point you guarantee is in here. 1, 1. So check it out. 1 plus 1 is less than 14. True? 1 plus 2 is 3. Is that less than 10? Is 1 greater than 0? And is 1 greater than 0? Hey, 1, 1 is in this region. It made all of them true. Now, what we don't see in here, which is a really valuable application of this, is easy extension. Could I ask you to find this point? And you would just solve the system of equations between the green line and the blue line, right? Could you find this point? It is where which 2 lines intersect? So you're giving me both answers. I love it. Red and blue, or those 2 equations. Could you find that point? Could you find this point and this point? Man, we could find the vertices, and maybe in some problems there's some really important stuff that might happen there, but it is beyond what we're doing at this point in time. Infinitely many solutions, we have it. Is this better than doing the diagonal lines and trying to find the overlap? Okay. Another one with your neighbors. I'm going to give us a much easier one rather than making us do a big one like this. Let's check it out. All right. One more quick and easy one. Then we're going to do a word problem. I think I'm going to push it back a day, what I had planned for this week, but we'll be hopefully all right with it. So let's see here. I want us to graph the following system of inequalities. You guys are welcome to grab colored pencils if you want them, but not required. So here we go. Let's say x plus y is greater than, 3. 2x minus 3y is greater than or equal to 6. Much simpler problem. I want you guys to graph and find me the shaded region. It might not be stuck inside like a polygon. It might go on forever. That's okay. I'm going to give you guys a couple minutes. I'll be walking around so that you can ask questions. And then after you have a little head start, I'll jump in and start working it, and we'll see if we get the same thing. Cool. First thing from this, we're going to pretend it's equal. If you want me to write it, I can, but I think we can all imagine that it's equal for just a second. If x is 0, what would y be? 3. And if y were 0, what would x be?
3.
So everybody okay that I get the point, and I'm going to go ahead and just jump by 3, and we'll make the other one fit. If that's 3 and that's 3, then I just got these 2 points on this one. Everybody on board with that? Solid or dashed? Dashed. Okay, so I'll just put some dashes here. And again, I will miss this like a million times. But here's my line, and I'll dash it. These things should go crazy fast to graph. If they don't, let me know, because there might be a disconnect somewhere. Now, rather than graphing them all, just so you know, I think these out in my head like right away. What test point might I use for the red one? 0, 0. So 0, 0. 0 plus 0 is greater than 3. Is that true or false? False. So that means this whole region down here is false. Which means this is where I get shaded, right? Yeah. Okay, I'm going to keep that in my head for just a second. We'll do the x's the same, but everything up here is where I'm thinking is shaded right now. For the second equation, I'm not going to solve it for y equals or anything like that. We're just going to jump right in. I'm going to use a solid line. If x is 0, what would y have been equal to? Negative 2. So if I have the same scale, and I'll just put the negative 2, so negative 3 would be about there. If I said this was negative 2, believable? Okay. What if y is 0? What would x have been? 3. So there's that one too. Do I have 2 blue points? I'm going to connect them. Now, in my head, again, I want to stress, we can do the x's every time. I'm good with it. What test point could I use for the blue line? 0 minus 0 is greater than or equal to 6. So it says 0 is greater than or equal to 6. True or false? False. So that means everything down here would have gotten shaded, right? This is a much simpler graph. There's only 4 regions. The most common mistake that people make is if you don't label your equations, which I'm not because I have the color coding, but if you don't label them, people try to stop shading at the axes. These axes, neither of those axes were my inequalities. We don't consider them to be splitting up my region. There's only 4 regions on the board. Now, if we do the same thing that we did, 0, 0, test, and I'm just going to do it in red. If we do 0, 0, it's false. Means everything up here got shaded. When I want to make sure that we don't stop at the axis, I'm going to put an X on the axis there and an X here. Everything above red just got shaded. Okay, give me a test point for blue. Okay, so for the blue one, test 0, 0. And just as a reminder, 0 plus or minus 0 is 0. Greater than or equal to 6 is also false. So I'll put an X down here underneath and an X here. Notice I'm putting them on the axis because we didn't have greater than or equal, X greater than or equal to 0. Is there a region that got hit twice? Yeah, it's literally where my cursor is. Once we have this information, we're good. Here we go. All of this, all infinitely many of these points forever and ever in these directions is my shaded region. Cool. These problems, as long as you can graph, especially you can graph from standard form, they should go super duper quick. Okay. We are at a weird time-wise. I always underestimate how long something's going to take. We have 7 minutes left in class. What I want you to do today is, if you didn't get 19 and 20, because we didn't go over this, again, Holloway was wrong. If you didn't do 19 and 20, I want you to do those tonight. But for the assignment this evening, super easy. All we have to do is add 2 problems. Okay, so let's see. Here we are in 9:15. Let me go here. And I'm going to actually make this, I'm going to add 1 problem because that is my bad. So 9:15, we did 19 and 20. Whoa. Anybody do 29 and 30 last week? Because oh, there we go. So we're going to add 2 problems. And actually, we're going to add one problem right now. Add 21 to the assignment. So you have 19, 20, and 21.
I'm just asking, what if you have negative 2, like just random, negative 2y is greater than 0? How do you find y?
You can't. So great question. I assume that you must be looking at number 19.
Yeah.
Okay. If we have something like this, so 19, 20, and 21 are due tomorrow, just so everybody's on the same page. Cool with that? Okay. There's a question already on 19. Hypothetically, if I had this as an equation, and we'll go here, and let's say we had something like y, or we'll do 2x is greater than 0. Okay. This line, you can't test 0, 0. So once you sketch it, you're going to have to pick any point. If you want to be safe, I know the point 10, comma 0 is not on this. I can plug in any point that's not on the line. So I lost you there. Check it out. If we, let's say this was our inequality, okay? Whoa. And here's 2x. And I know it goes through that point, and then it goes up 2 and over 1. So here it is. Okay, and we'll make it or equal to, so it's solid. You can't use 0, 0. Give me any point that's not on this line. Yep. So 1, 1 might not be. I would pick a better one. You're right, it's not. Could I pick 1, 0? Okay, if I picked 1, 0, I would get 2 is greater than 0. True or false? True. It says, hey, here's that point I tested. I would shade all of this down here. Cool, cool?
Yeah.
All right.
Just doing that to find that x point. Like, instead of shading, I was trying to find a point in that part.
Like to test?
No, like to make the line.
Oh, I would use, so I agree. This is mx plus b in this form.
Okay.
Cool. So it's 2x plus 0. 0, 0, up 2 over 1. Okay. All right. I'll let you guys get to it, and then tomorrow we're going to do a couple word problems and something else that's super fun.